Hello everybody, my name is Yifan Yuan and I'm from Augustana University. This summer, I worked with Dr. Nathan Grau on Pythia study of rapidity-separated two-particle correlations in 200 GeV proton-proton collisions. Measurements indicate the nuclear modification of gluons in lead is suppressed compared to proton at low x. Phoenix has measured pi0 correlations in 200 GeV deuterium-gold collisions at forward rapidity. Their wayside yield is suppressed compared to the same correlations in proton-proton. An open question is, does the wayside width change in deuterium-gold compared to proton-proton? We want to use Pythia to study the partonic kinematic accessible to two-particle correlations. In this case, we use Pythia 8.2.35 with the following parameters. As a check on the output, we looked at the fraction of single pi0 at forward and mid rapidity from different partonic collisions. Mid rapidity means the absolute value of eta smaller than 0.35. The forward rapidity means eta range from 3 to 3.8. In both rapidity ranges, from 2 to 5 GeV per C, the pi0s come from mostly low-energy gluons in the gold and quarks in the deuterium. We also look at the pi0 PT dependence of Q² and X gold. We built the pi0 trigger and associated hadron correlations at different rapidity. In Figure 3, the trigger pi0 is in mid rapidity. In Figure 4, the trigger pi0 is in forward rapidity. The charged hadrons are in several different rapidity. Mu on south is a range of eta from -2.2 to -1.4. Central is the absolute value of eta smaller than 0.35. Mu on north is the eta range from 1.4 to 2.2. MPC north is the eta range from 3 to 3.8. We fitted the wayside with Gaussian and fitted the near side with another Gaussian as well when it was present. The wayside width is the standard deviation of the Gaussian fit. We plot them as a function of pair pseudorapidity and X gold. As shown in Figure 5, the wayside width broadens with the pair pseudorapidity for central triggers. The wayside width narrows when the pair pseudorapidity for forward triggers. There is no strong dependence of the wayside width with X gold. Right now, we are looking at 2016's Phoenix deuterium gold data at 200 GeV, and this results indicates that we should focus on pi0 from 2 to 5 GeV per C and measure hadrons at different pseudorapidity. Thank you for listening.